Okay, this is the second revision video for C1. This follows on from fundamental ideas, and we're just looking at how atoms react in chemical reactions. So when we have elements reacting, so things off the periodic table, what's actually happening is the atoms are reacting and they're joining together to make new compounds. So they might have already been a compound and then they're going to change and they're going to become new compounds. We're going to break bonds and make new bonds. So we can either have metals and non-metals, so the left and the right hand side of the periodic table reacting together. And if we have a metal and a non-metal, we're going to take or transfer the electrons in the outer shell. So metals tend to be in group 1, 2 or 3 of the periodic table. So they've got 1, 2 or 3 electrons in the outer shell, and the non-metals on the right hand side of the periodic table. So they might have 6, 7 electrons in the outer shell. So in order to get a full outer shell, which is what they both want, the metals are going to lose that electron or 2 or 3 electrons in their outer shell, go to their next full inner shell, the next one underneath, and then they're going to give them to the non-metal, so the non-metal can fill the gaps in its shell. Okay, and what that's going to result in is both of these now are going to be called ions, because they're going to become they're now charged, they're unbalanced, so they're going to have more or less protons than electrons are going around the outside. So metals will lose electrons and become positive, and non-metals will gain electrons and become negative. So because that's positive and that's negative, they're now attracted towards each other, and that's going to form a compound. Or you can have non-metals and non-metals reacting. Okay, and if non-metals and non-metals react, that's on the right hand side of the periodic table, so that's group U 7, 5, 6, 7s. That involves sharing of electrons. They join together and they share electrons, and by doing that, they both achieve that full outer shell. But because they're sharing and not giving or taking, they remain uncharged. They don't have that charge that the ions have. So we're now going to call that a molecule, because we've now got two atoms, two or more atoms joined together. That's now going to be called a molecule, and they're joined by what we call a covalent bond. Now for C2, you need to understand and be able to draw ionic and covalent bonds, but for C1, you just need to know that a metal and a non-metal make ions, so become charged, and non-metal plus a non-metal makes molecules. And they share those electrons and they form a covalent bond. Covalent bonds are really, really strong, so they're very hard to break, okay? Now, chemical reactions might be shown in your exam by word or symbol equations. They can be both. So here's an example. So this is the word equation at the top. Please make sure that if they've shown a word equation, they want you to fill in the gap, you fill it in with the word and not the symbol, because often you can lose marks for that. So here we've got sodium plus oxygen makes sodium oxide, and here we can see the symbols Na, O2, Na2O, okay? And we've then balanced it with the larger numbers at the front. Now balancing could come up, but if it comes up, it'll probably only be on the higher tier paper. It probably won't appear on the foundation. If you're not sure how to balance, the first thing you're going to do have a look at is the number of atoms on both sides, okay? The reason being that we know for conservation of mass, this is a rule in chemistry, that we don't lose or make atoms in a chemical reaction. So no atoms are lost or made during chemical reactions. So the mass of reactants, everything on this side here, is going to be the same as the mass of products, so everything over here. So imagine like a seesaw, this side must balance that side, okay? And we need to help balance it if it's not balanced by adding in these big numbers, okay? You cannot do anything with these small numbers because that changes the formula, so the chemical makeup really of this bonding over here. So we're not changing that, which is going to change how many atoms or molecules we have of it to balance it. So if we look here, the way I normally do it is do a table underneath, and we add up how many atoms are this side, the reactants, and how many atoms are in the products, and then we can work on balancing. So here we've got C3, H8 plus O2. So we've got 3 carbons, 8 hydrogens, and 2 oxygens. On this side, we've got 1 carbon, we've got 2 hydrogens, we can see there, and we've got 3 oxygens. We've got 1 there and 2 there, which makes 3 overall. So we can see that we're not balanced here at all. So we need to try and balance. So we've got 3 carbons this side, and we need 3 over here. So we can start by putting a 3 here. And what that does is that changes that to a 3. But it also changes our oxygen. So this becomes 6 plus that is 7. Okay, so you can see here 3 times 2 is 6 plus this one is 7. Now our hydrogens are out. So we've got 8 over here and we've only got 2 over here. So I need to make this up to 8. So I can do by adding a 4 here. So if I add a 4 in there, so that now becomes 4 times 2. That becomes 8. But I've also changed my oxygens. So I've now got 4 oxygens here and 6 over here. So that makes 10 in total. So I've got 4 plus 6, that makes 10. So I've balanced my carbons, I've balanced my hydrogens, but my oxygens are now out of sync. So I've got 10 oxygens on this side, but I've only got 2 here. So how can I make that 10? I can put a 5 there, because I've got 1 molecule of oxygen containing 2 atoms. So if I've got 5 molecules of oxygen, then that makes 10 there. And that is now balanced as well. So I've got 3 carbons on both sides, 8 hydrogens on both sides, and 10 oxygens on both sides. That is now balanced, okay? That's a skill you need to have. There's loads of balancing equations practice on the internet. If you just type into Google balancing equations worksheet, you'll find plenty with answers. So have a go at those and practice those. If not, just have a look through some past papers and you'll find those. But that could be worth a couple of marks in the exams. It's well worth having that skill. Okay, so that's chemical reactions for C1. So knowing that when elements react, atoms join to make compounds. We're going to have metals and non-metals. And if we have a metal and non-metal, so 2 different things, we have to give and take electrons from one to the other. The metals lose and become positive. The non-metals gain and become negative, and we form ions. With a non-metal and a non-metal, they're the same, so they'll share together and they'll share electrons, so just those things in the outer shell, and they make molecules and they're joined by a covalent bond. We can have word or symbol equations to represent chemical reactions, and we know that on this side of the equation we're going to have the same mass of reactants because we're not going to lose or gain any electrons, so the same over here as that over there. So we can use that idea to help balance equations. Okay, that's the end of the second part then of C1.